Hi there, how are you? Welcome to Maths for Data Science. This is Vivek. In this video, we will understand how we can use pandas to rename the columns, update the data, sort the data, and add and remove the columns from the pandas data frame. So let's get started. Let me import that pandas data frame, and I will import the Stack Overflow data, which we have already used in the previous videos. So here I am making a copy of it. I will tell you why I am using a copy method here instead of doing df2 equal to df. Just wait for some time and I will let you know. The first thing is we will learn how to rename the columns of a data frame. So first thing we have to understand df2 columns when we do, then the output is a list. So we can consider it as a list and update accordingly. So this particular example has nearly 83 columns, 84 columns. So suppose you would like to update all the columns and you know that you would like to rename it as a change 1, change 2, change 3, change 4, and so on and so forth. That you can do it by creating a list which contains that information. So let me execute this thing separately and show to you. So now the output of this list comprehension is this, and suppose you would like to change it everything in this particular manner. So after creating this thing, you can assign it to variable, say v, and instead of this thing, let me replace it with that variable. And when I execute it, this, okay, there's a typo error, I believe. B is not defined. It means I did not execute it properly. Let me do it again. Right. So now what it does, it has taken this list which is present in V and replaced every column name present in these columns. So let me print the column names now. df2.columns. You will get the clarity. Now you see every name in the column is changed to df, change 1, change 2, change 3. That's how you can do it if you would like to change entire list of columns, or you can create the list exclusively. Suppose you would like to rename first column as A, second column as B. So you have to do it manually, and so on and so forth. You have to give name to each and every column, and then you can directly assign that value to df dot pandas data frame dot columns, and it will rename the columns. That's a one way. Second way, I will tell you that either you can use a rename method available in pandas. In that, you have to pass the column. You have to pass a dictionary in the columns parameter. So here I am passing a dictionary. So the key value is nothing but the existing name of the column, and the value is the new name of the column. And here I'm using an in-place parameter available in this rename method to make the changes in the existing data frame, that is df2. Now if I print a df2 columns, here I have again create a copy. It means it will not have a change 1, change 2 thing. However, it will have the original column names. And here if I go and see, the name is changed to salary USD. And now next thing, you might think why I did not use the option which says df2 equal to df. Why I did not use it? Let me show you. If I use this particular assignment operator and see the IDs of both the data frames, you see both the data frames is pointing to the same object. It means any changes I will do in the df2 will reflect in df also. But if I do df.copy and check its ID, sorry, spelling mistake, df copy, and if I check it, you can see both the data frames is pointing to a different object. It means any changes I do in this thing will not affect this df. We do so to keep copy of our original df and do all the operations on the copy, because in later in the program we might require to refer back to the original data frame. That's why we make a copy rather than doing the changes in the original df itself. So let's move to the next part where you update the data. Here also, as we have done some changes here, I'm just again creating the copy of df in df2. Now here, the one way of changing the data is replace. You can see I have used a couple of values here. So how did I find this value? So to finding the unique values of a particular column, you can run df column name and a unique method. It will list down all the unique values of a column. Here we have nearly 4 unique values of a particular column, this AI select column. So here I am just replacing no with false. Anywhere I see no, I am replacing with false. And let me execute and show it to you. And when I say AI select, Yes is one of the values in this column, but I did not replace it. So this is as is, but and anywhere I can see the no, I have replaced it with false. That's how you can do it. But you have one more option, which is a map method. Let me show you the difference between map and the replace. Here, if you see, I am using the same dictionary, because here I have passed a dictionary. I am using the same dictionary here. Only difference is here I am using map instead of replace. Now, if I execute it and give you the output, there is a big difference in the output. Let me show you. Now, if you see here, where I did a replace option, where I did not replace the yes, you can see the row number 2 is yes, row number 5 to 10 is yes. But with the map, if I see row number 2 is translated to nan, and 5 to 10 is also translated to na and nan. Why it's happening? Because replace is just replace the data which is mentioned in the dictionary. So if I say XYZ needs to replace with ABC, it will replace only that data. But map, what map does is, if you have given certain values, that will replace it. Any other value present in that data frame, it will replace it with nan, NaN. So that's the main difference between map and nan. Move to the next part. Now, suppose you would like to update a particular data point in a data frame. So for that, I am saying df2. Let me print the head. So now suppose here I would like to replace this thing with certain value. Here in this case, I'm replacing it with test. I can do that. So as it's a second item, so here I have to mention the index is second, because this is the index. The index starts from 1 here. So this is a second index. I'm replacing employed, comma, full time with testing. So let me replace and again print the head. Here you can see the data has been updated. So this is a one way to update it. There is a second way where you have a list of, you would like, there are n number of columns which you would like to update, and you would like to update only particular row for those columns. So in that case, you can mention the column row number or the index, no, not row number, the index, and the list of the columns. Here, if you remember, if you see, I have mentioned the list of the columns in in the square brackets. I have enclosed in the square brackets. That's how you mention. When you mention more than one column, you have to mention it in the square bracket. So you have to mention it as a list, not as a string. Okay. Now I'm saying that these three columns should be replaced with this list. The first element of this list represents the value for this particular column for row number 1, the new value. The remote home, it represents to the remote work column for row number 1. So let me execute and show to you. Now if I print the head again, so I'm taking this particular value, so this should be updated. Let me execute it. Now you can see the employment for index number 1 is changed to full-time, remote, and this. That's how you can do it for multiple rows. So for you can do it for multiple columns. And now suppose you have a situation where you would like to update the data in multiple rows for a particular column. You can achieve it by applying some filters on the data. So in the previous video, we understood how we can apply the filters. So let me first print the head to show you that in this employment, I would like to update wherever I see employed full-time with full-time, suppose. So now I am making a filter. So this is the same kind of filter we have used in the previous video, that wherever I see employed full-time, okay, just validate that particular rows. So when I say validate it, wherever it matches this particular value, it will give the output as a true, and wherever it does not match, it will give us output as a false. Here I have used a match method. In the previous video, we used the contains method. So the difference is pretty much explanatory. Contains is, it's a partial match. If certain part of that data point contains that word, it will give us a true. But in this case, in match, the entire data should match, then only it will give us true. Let me print this out also. FILT filter. So now we got our output as a false and true. And now what I'm doing is I'm passing that value here. So you understand, if I do like this, what kind of output we'll get it in the, and we learned in the previous video. Now I'm saying wherever you have the true, you will get the data in the output. Now I'm saying in the employment column, so it means wherever true, employment column update with full time. If I execute it and show you the output, now you can see wherever it was employed full-time, it is replaced with full-time. Okay, just to be assured that it has only replaced the employed comma full-time, you can see there is a different value here. It means it has only updated the data points where we had employed comma full-time. So that's how you can update the multiple data points based on the condition. And it's this particular filtration condition is not limited to only one column. You can create a complex filter here, as we have learned in the previous video. You can create a complex filter and you can apply it on a multiple rows. I will leave it on you to experiment with multiple columns. Here I just mentioned one column. Create a filter with multiple columns and try to update it here. That's a homework for you. Just practice that point. If you have any questions or you're facing any challenges, please put a comment in the comment box. I will address it. So next part is, there are good amount of chances that your data points might contain the NA values. So for filling the NA values, Pandas provide you a fill NA method available. So you say fill NA, and whatever value you would like to put it in that NA place, you can mention it here. And I'm using an in place parameter, so I will execute it. So it will update the NA values with none for employment. But suppose you would like to update it for the entire data frame, then remove the column name and simply run dataframe.na and the value you would like to be replaced. And you can mention the value which you would like to replace NA with. So it has given me the output. If I run it, we have at the row number 10, we have NA. So which column it is? The column is remote work. Let me print and show to you. Let me print it here. Row number 10 or index number 10. Now see, it has been replaced with none. So this NA you can run on a particular column or you can run on entire data frame. The next approach is using the apply method to do some changes in the data frame. So first, suppose you would like to find the length of each and every element in the data frame, you can do a apply. So apply is a method in Pandas data frame. We can use apply to run any function on each and every data point. So it means that this length is a Python method which gives us the length of a particular string. So we can apply on each and every element, or you can create a custom functions also to achieve that. So that I will show you. First, let me execute it. Now you can see on the employment column, the length is applied, and for each and every data point, it has given the length of that particular data point. Now you can create a custom function. What this function is doing, whenever we have the string, it's returning the length of it. If there is no string, it's just returning that data point. So I'm applying this uppercase. So now you say I'm using apply method. In that I'm passing my custom function, and here I'm not passing with the brackets, but I'm passing as is, just like a variable. And if I execute, and let me show you now if you see, if I run this and see the output is the length of that data point. So what it happened now, after running this particular thing, I have assigned this output to the employment. Now this employment does not contain the original value, but it contains the length of each and every data point. Just to give you more confidence, let me print the data frame head. Now you can see this employment does not contain the original value, but the length, because the output I have assigned to the employment. That's the reason here we don't see the original data, but the length of those data points. So here, now we have used this apply method on a particular column. What happens if we do it on the entire data frame? Let's see the output. So now if you see here, let me rerun it. So when I apply it, if you see, these are the column names. These are the column names, and these are the count of the data points in that particular column. So when you run apply on a data frame, by default, it will go to each column and see the count of data points in that particular column, because we are applying length. So what if you pass the custom function also, it will apply on the entire column, not on individual data points. Okay, now this apply has a two options. Either you can do a row wise or a column wise. So by default it's a row, that it is giving you the count of data points in each and every column. If I change the axis to columns, then it will give me in a particular row how many data points it has. So it gives us the count of columns, that for index 1 how many data points we have, index 2 how many data points we have. So I think you got that point. Let me show you one more thing. Now, that's fine. That now you would like to apply a particular function, be it be an inbuilt Python method or user-defined function on each and every data point of a data frame. That you can achieve using apply map. So apply, if you do only apply on a complete data frame, it will be applied on a columns, not on each and every data point. But if you do apply map, it will be applied on each and every data point. Let me run it and show it to you. Now here you can see the output data frame is the count. So Q120, the first element length is, first data point length is 7. Here if you see the 1972, this output data frame we got it. If you do, and it is applied on each and every data point in the data frame. So that's about the apply. Let us go to the sort. I will create the data frame again. I will copy the data frame again. Now to sort a certain column, we have inbuilt sort values method. Here the main or mandatory parameter is a by. Here you can pass a list or a string. Here I'm sorting with only a single column, so I have passed a string. Here you can pass it as a list also, it will still accept. But for multiple columns to sort, you have to pass as a list. But for single column, you can pass as a string or a list. Both is fine. So ascending is true. By default, ascending is true. Mean it will go from lowest to highest. In place, you know what exactly in place is. So if I run, and as I do in place, it means the changes will be done in the data frame itself. df2 dot country. Now you see it's been sorted ascending order. Okay, now you're sorting on a multiple columns. Now as default, here I did not do in place, that's why it has returned a data frame. In the previous example I have used in place, that's why I did not return the data frame. Why? Because it has done the changes in the data frame itself. Now this output, the country and comptotal both is sorted ascending order, and by default ascending is true. If it's a false, then it will be sorted in descending order. Now suppose you would like to sort one column ascending, second column descending. That can be done, but instead of passing ascending equal to true, you have to pass a list telling about how you would like to sort each and every column. The first column I would like to sort as a ascending, second column I would like to as a descending. Because ascending true, then ascending for this column is false. I'm doing in place. Let me run and show it to you, and let me print the data. Now you can see this country is sorted ascending order, but this comptotal is sorted descending order. The maximum value is at the top, and the following values are lower than the top value. So next thing, you might want to find out the n largest numbers in a particular column. That you can achieve using the n largest method. So here I'm taking the 10 largest numbers. So these are the 10 largest numbers you have in the data frame, and the first one is clearly man-made, so it's not originally a salary. Anyone can have it in the universe. So same thing, if you would like to find the smallest 20 numbers or 10 numbers, that you can achieve using n smallest. And the next is sorting the index. This we have already done in our previous video, where it will sort the index. Let us do ascending as false. Let us do ascending as false. Now you can see the entire ascending equal to false. Here you can see it is sorted on ascending order. If I do ascending into false, it will sort me in the descending order. Now you can see it's in the descending order. So that's about sorting. Let us move to the add, remove rows and columns. For that thing, I'm using a small data frame because it will be very easy for me to explain you, and it would be very easy for you to absorb the concepts. So I'm creating a small data frame, and the similar data frame we have used in the previous video also as a code snippet. So I'm creating a data frame. Now you would like to concatenate two columns and create concatenate first and last and create a full name column. That you can do by simply using the plus operators. So now if I run it, it will give me this output, but this has not been assigned to a column. It means the original data frame is not affected. And for that thing, I am assigning this particular thing to a column. Here, if you see, the full name column does not exist in the df underscore one. And when I do like this, what Pandas knows that you are willing to create a new column, which would be a concatenation of these two columns. And now let me show you the output of this. So now you can see a new column has been created. Now you would like to drop certain columns. That you can do using the drop method. In the columns parameter, you have to pass the column names. You can pass a list or a string. Here I would like to drop two columns. That's why I'm passing a list. For one column, you can pass a string or a list, but more than one columns, you have to pass a list only. Here I'm using in place to do the changes in the original data frame. The next is snip full name. Now full name, I would like to split it. So this split we have already seen in the previous video. Only additional things additional parameter we see expand equal to true. What it does, let me show it to you. When I run only this much code, you can see each and every data point is a list. If I do the expand, it will expand the list and create the columns for us. Now see that particular list is been expanded and a list or a new data frame is created where the column name is 0, 1, and these are the indexes. Now I would like to, now here we have dropped the first and last name. Suppose we have the full name with us and you would like to split and create two columns, first and last. You can do it by just assigning this output to columns. Here, if you observe, here I have given a two column names. So, but if you remember, I mentioned that if you have more than one column, you have to mention it as a list enclosed in square brackets. So what it does is whenever this code is executed, so it is created two columns. This first column will be assigned to this first, and this column will be assigned to last. So let me execute and show it to you. Now see, the first Vishwa Kalisha Sai Aziz is assigned here, and last assigned here. The next part is you would like to append some data to your data frame. That you can do using append. So here I am passing a dictionary. So the first is nothing but the column name, and the Tony is nothing but the value. If I pass it, now you can see when I execute it, I am getting the output. The first value is a new row is added, and the first column we have a Tony now, and any other columns is NA because I did not update the other columns. That's why. Now, second thing is now you have only updated you have appended a particular value to a column. Now you would like to append two data frames. That you can achieve also. Now I'm creating one more data frame, which is snippet 2. Let me print the output first. Now I would like to append both. Now the syntax is first data frame dot append the second data frame. Ignore index. I will tell you what exactly ignore index is. Let me execute and show it to you first. Now if you see here, with this ignore index, initially the values are 1, 2, 3, 1, 2, 3, 0, 1, 2, 3. So this fourth value will not be shown here because I did not assign the output of this append. Here you can see we have a fourth element, but after appending with df1 and df2, the snip and snip2, that value you have here. Sorry, that value does not exist. So if you see here, we have added a Tony here, the fourth element, but that does not exist after doing the append. Why? Because after doing the append, I did not assign it to df snip1. So that's why we don't see. If I would have assigned it to df underscore snip1, means when I say assign, I'm going to say something like this. If I do this and execute the code, then you can see here. So that particular value you can see here, and the sixth row will be created. But I did not do that. That's why that particular value is not showing. Now the next part is what's the difference between ignore index, or what's the use of it. So let me show it to you. I am removing the ignore index and executing. Now here you see 0, 1, 2, 3, 4, 5. If I execute without ignore index, you can see 0, 1, 2, 3, 0, 1. This 0, 1 belongs to the second data frame. So it means it will take the indexes from the data frame and update it here. If you make it ignore index, it means it will not take those indexes, but it will increase the indexes. That's the reason we use ignore index there. Most of the time in our data, when we append two data frames, we would like to do the ignore index because we need the indexes to be unique. And now I'm assigning it to the diff stipend, and if I execute it, now you can see you have those 5 data points. Now previously we have seen we have dropped 2 columns. Can we drop the rows also? Yes, we can drop. To drop a column, we used column keyword available in the drop. Let me scroll up and show to you where is drop. We have used the columns keyword. For rows, we have to use index keyword. I'm saying index drop the 4th element from here. If I do it, it will drop the 4th element. Now you can see the 4th element, but if I run that snippet, you can see it exists here because I did not do in place here. So I'm doing the changes, but if I do in place equal to all. Okay, let me keep as is because I have used in place later. So here, if I do something like this, in place equal to true. Now, if I did in place equal to true because it has that argument or parameter. And if I execute it here, now you can see the 4th row is deleted. Okay. Now that's fine. Now you said Vivek, but it's very difficult to delete or it's very difficult. It's very cumbersome task if the data is very huge. You have to find out the index or the row number which needs to be deleted, and then you have to drop. That's a very cumbersome task, but we can overcome that particular challenge. You can create the filters which I have already explained in the previous video. So here I've created a filter which says wherever the last is RAM, validate that, means wherever last is RAM, make it true, and for any other scenario, make it false. So let me show the output. So this is the output. Now, if I run dot index on this thing, I will get values of these 2 indexes also, 2 and 3 only. And that output I can directly pass it in this drop. And if I do so, you can see the output that index number 2 and 3 is deleted, only 0 and 5 is left. And here if I use in place, it means it will do the changes in the existing data frame. And that's what about today's video. Please go to the description for coding exercises. In the next video, we will learn a couple of more methods available in Pandas data frame to do the number crunching to analyze the data. For any questions and concerns, please leave a comment in the comment box. I will reply to each and every comment. So let us meet in the next video. Till then, I am Vivek signing off. Bye-bye.